Let's go live. Okay, we should be live now. Welcome to day 5 of Advent of Code. Let me put the link in the chat and pin it to the top. There we go. Okay. So a friend already told me that today was probably going to be another easy one. So yeah, let's find out, shall we? Day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship is a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and rearrangement procedure, your puzzle input. For example, okay, looks like this will be a bit of a challenge. Parsing. Let's see, move 1 from 2 to 1. Okay, so that will take this one and go here, I think. Let's see, in this crate there are 3 stacks. Stack 1 contains 2 crates. Z is on the bottom, N is on top. Stack 2 contains 3 crates from bottom to top. They are crates M, C and D. Finally, stack 3 contains a single crate, P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, one crate is moved from stack 2 to stack 1, resulting in this configuration. Okay. Yes. Hi, welcome. In the second step, 3 crates are moved from stack 1 to 3. Crates are moved one at a time. So the first crate can be moved D. To be moved D ends up below the second and third crate. Wait, what? Let's see. Move 3 from 1 to 3. Ah, okay. So it takes all 3 of them. Ah, but when you move more than one, you reverse the order. Okay. Oh yeah, it just does the same thing multiple times. Okay, so it's like a repeating thing. So move 3 is the same as 3 times moving 1, because you only take 1. Makes sense? Okay, so the first crate to be moved D ends up below the second and third crate. Okay. Then both crates are moved from stack 2 to stack 1. So that would reverse the order, okay? Again, because crates are moved one at a time, crate C ends up below crate M. Finally, one crate is moved from stack 1 to stack 2. Okay? The elves just need to know which crate will end up on top of each stack. In this case, in this example, the top crates are C in stack 1, M in stack 2 and Z in stack 3. So you should combine these together and give the elves the message CMZ. Okay. After each rearrangement procedure completes, what crate end up on top of each stack? Okay, let's see how wide our list is. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Just by saying hey, coding. Just by to say hey, coding hurts my tiny brain. It's a lot easier than when you finally get to know how everything works. It's not all black magic, and everything can be broken down in tinier bits of logic. Yeah, and by the way, I'm addressing the chat in case you're wondering who I'm talking to. So yeah, it's the live chat. You can replay that after. So yeah, coding isn't black magic. It's very learnable and it's a lot of fun when you learn how to do it. So I can recommend it to everybody to learn how to code because it's amazing. I discovered coding when I was 12 and it was like magic to me. Like being able to create anything that I wanted, it's just, yeah, the best feeling ever. So let's see. Let me just copy this into our code editor so that we have an example. I already made the day 5 thing here. Let's do a multi-line comment to put our reference here so that we know what to address. So basically, if you split it by space, you have 1, 2, 3, 4, 5, 6 items, and basically the first one is the repeat, the source and the destination. So we can split by double new line. Let's go back to the input here. Let's see, there's the input. So yeah, if we split by double new line, we separate the header from the bottom. So let's start with that. So let's do string input is input dot split by, and this will be a, let's see, just care like 9 got the wrong indentation. Ah, okay. Yeah, parsing this will be a bit tricky, but it will be okay. Also, I think the first line is misaligned, right? Let me see. Yeah, for some reason the copy paste went wrong for my first line too in this example, so let me just put that here again. Yes, that's better. Let's see. I think I should be able to do this. Let's see, var assignment is that should be it, right? And now I can do yeah, so I can do this will be string header string lines, and probably I can do better than this because the second part I can do 2 lines. So now this becomes a list of string. Like this. So this is my my helper, where I can just transform things easily. So I take the input, I chop it in 2 bits first, then I make it to an array so that this one triggers. I should probably make this one accept an IEnumerable as well, but yeah, we can do that later. And that would remove the need for this one. Let's see, assignment. So you have that. So the header and the lines are 2 separate parts. And we could actually go further, because for each line we can do dot select, and we do x.split, and we do that by space. And that makes sure that we move it like this. Let me just make a small helper function here, so I can do int repeat count, int source, int destination, parse instruction, string instruction. So let's remove this for now, and then we can do string parts is instruction.split by space. That will give us this one. So then we can do const repeat index is 1, source index is 3, and then destination index is 5. Right, now we can do return parts repeat index. I need to specify that these are integers, repeat index. We have parts source index, and we need to parse those as integers as well, and then parts destination index, and each of these need to be parsed as integer. So we can do int parse and just do that every time. So now we have a helper function to parse this. So now we can do .select x, parse x, like that. And now our lines will actually be a list of instructions. So we can do instructions, and now we have that parsed. Let's see. And now we need a way to parse this. And basically, it's a fixed width, right? So we should probably go from the bottom to the top and skip this line. So we have a dictionary of first the index, and then we have a stack of char columns. Blah. We can probably also just say parse header, string header. We do for result is what? Okay. Let's take this example from here and put it here. Okay, and we need to say var lines is header.toLines, like that, and we do for I is int I is lines.length -2, I smaller than 0 plus I, and this walks backwards, skipping this one. And then, let's see, because it's 3, basically it's 4 characters for each, but the last one isn't padded. So we do int columns is, let's see, is const int chars per column is 4. And then we do int columns is lines length -2 dot length +1 divided by chars per column. Okay. We should also do for int I is null, I smaller columns dot length count. It's just columns. Sorry. And then we need to add a new stack to each to the result. So we do result add I comma new of that. And so we do for int goal is 0, goal smaller than let me take this variable here, int header width is this, because we need to do that. Header width, col smaller than header width, we do col plus is chars per column. Okay, so now we can walk through the entire line, and we can do if string, let's define that here, string line, do line is lines I, and then we check the character to see if there's can say const char empty is space, if line col plus 1, because we start at the bracket each time, isn't equal to empty, then we say result, yeah, I can divide that, I could also multiply it, but I think keeping a running total is easier, so I'll just do current col is 0. Actually, I need to do that every time, so I can just do here current col is 0. So I can do yes, current col push, and then we push the character. Let's also define it here, char value. So we can do val is this. We push the value. Okay. Return result. Okay, so this should be our header parser, and we need to increment this every time. So normally I would do that inside this assignment, but since it doesn't always trigger, we need to separately increment it. So yeah, that's the header parsing. So now we can also put that in our mapping. So instead of header being a string, we can just do call this stacks, and we do parse header x. So now we have our full input parsed. So let's set a breakpoint here and see if that actually works. Boom, index was outside. Wait, I is like, do I have nested i's? Wait, let me see. I need to decrement here. When you build a reverse loop, make sure to decrement, not increment. Okay, let's see. So now we have our assignment here. So we have our 9 stacks. These are the instructions. Let's compare that to the input for a bit. Where is it? Here. So let me put this side to side. So the moves seems correct. Let's jump to the end to make sure that the last one is there too. 159, yeah, okay, so that is parsed, that is correct. Let's look at the stacks. SB, HV, FG, and the last one JQ, V, P, G, L, F, okay. So now when we look at the last one, and we do dot peak, why not? Let's see, assignment dot stacks 8 peak. So it says J on top, and that is exactly what we want. That's why we use a stack. So yeah, input seems to be correctly parsed. Shall we probably write the logic now to actually execute those instructions, and then peek every stack. So yeah. So we can do a void execute, and then we take this as the input. Right. Okay. Just a bit wide for the declaration, but should be fine. So yeah, we do for each I don't like the auto-generated one. Let me see. For each var assign instruction in assignment.instructions. For I is 0, I smaller than instruction dot repeat count, increment I, and then we take char val, okay, int val is, and we do assignment dot stacks I. No, first need to get the instruction locally. Oh no, we have that. We have instruction dot source dot pop, and actually we don't need an intermediate value. We can just do. We can just push it. Instruction dot destination dot push val. So I can do it like this, or I can do it as a one-liner and do it like this. Since we don't need to store it, we can do it like this. So yeah, so we can do execute assignment, and then we can do string builder. I need to import that. Do string builder, and do for I int I is 0, I is smaller to assignment dot stacks dot count, and we do sv dot append assignment dot stacks I dot peak, and then we do console right line part 1, and that should be sv.toString, right? Okay, so that should basically be the full logic for this. Let's see what it does. Boom. Ah, they're not 0 based. That's a good thing to note. Okay. So let me just offset that here. We do -1, -1 after the parse. Very smart, do it after the parse. So that's something that I didn't pick up on while reading. So all the indexes for the move instructions are one based, and it actually shows it here. While when you do coding, usually everything is 0 based. So let's run it like this again. And I need to do that here as, wait, I'm an idiot, because I need no, wait. Wait, what happened? Let me check. Stack empty. That is weird, and that should not happen. Let's try the input, the test input, and see what that does. Boom, 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 boom. like that. And then we need to make sure this is split like this, because I'm on a Windows machine. The 2 lines works. Stack empty, okay. That is weird. Let's see, move 1 from 2 to 1. Let me see if the assignment here is correct. So this was NZ, yes. CM P. And then the instructions is move 1 from 1 to 0. Then move 3 from 0 to 2. So that should work. Then move 2 from 2, yeah, that should also work. And then move 1 from, that's interesting. Let me see what I did wrong. So this pushes. So now the first one has 3, right? C and Z. Let's see. Wait, was that wrong? Let me check. Let me compare. Let's see. Yeah, the last one has P. Wait, that's weird. Because my second stack only has 1. Okay, let me check this again before I'm going crazy. Let's see, assignment. Was one of the stacks lacking? Let me see. Yeah, it didn't pick up 1 here. So in the parsing there's a bug where the top row didn't get parsed. And that is probably due to the header parsing not having an equals. Yeah. This is my bad. I'm missing 1 character here. So now when I run this CMZ, okay. Right, CMZ, okay. Let's go back to the real input. So that's an off by 1 error, and it's very common, and especially when you're used to writing loops going up, you never include the upper bound because that's out of scope. But when you go down, you actually already limit your upper bound and you have to go to the actual 0 element. So that's why when you write a reverse for loop, you always need to test for bigger or equals instead of just like the other way around. You just test for smaller than length usually. So yeah, that's what happened there. It's a very common bug. And even after more than 20 years of programming, writing stuff up quickly, I still make issues like mistakes like that. So don't feel bad if you do similar things. So let me just remove the test code here and run the actual code. Okay, so now it runs and it completes instantly. So let's put this back on screen and submit. Woohoo! Got there in the end. So yeah, usually it's stuff like this. The small little bugs in your code can take a lot of time. Let's see what part 2 brings. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. A crane isn't a crate mover 9000, it's a crate mover 9001. The crate mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Yeah, this is what I expected. Again, considering the example above, the crates begin in the same configuration, moving a single, etc. However, the moving the 3 crates, okay, so you do that in the reverse order. Actually, in the order that they are stacked. So that is fine. Let's see. They move, they retain their order as well. Finally, single crane is moved, blah, blah. Okay. So there's a few ways we can do this. A funny way would be to actually add a single stack into this as well, and just, if the repeat count is more than 1, just push the items that you need to rearrange, push that onto a new stack and pop it there and do it like that. So that is one way. And I think I'm going to do it like that. So bool use substack. Actually, you know what? I'll just, because then it needs to execute that bool every time, it's better to keep write a new function so that you don't have to execute the same bool logic at the same time. Execute with substack. So now what we can do is a stack char. We could call it a queue, isn't it? No, that will be too substack. Let's just do that, because the queue is like a stack, but it uses the reverse order. So I could have actually rewritten the logic, but it's fine like this. So what we can do is if instruction.repeat count is 1, else we do this, right? So now instead, what we do is we do substack, the push, and then here we do substack the pop, and we can do while so if we do it like this for part 2, that should keep the same order, because we pop it off into a new queue and then do kick it out in reverse again, keeping the same order as they are stacked. Let's just copy paste this to part 2. Get rid of this stuff. And let's see if this works as I have it in my hand. Let's see. It'll give a different outcome, so probably. Woohoo! So yeah, that's basically it. For those that didn't caught it exactly what I did now, let me take MS Paint. I love MS Paint, it's just so easy. I have Affinity Design, I should probably use that more, but so when you have 3 crates, boom. With a stack, you take from bottom down, but what we want to do is keep actually the same order. So what we do is if you take this and push it into a new stack, that will have it reversed. Because it will push them one by one. And I actually didn't do it reverse, that's nice. So if you push this one off, it goes to here, then it takes the next one, and then like this. So this substack that I wrote just creates a new stack that's aligned like this. Then when you use that again to push it onto another one, it will reverse it again, putting it there, and then it goes back to the original order. So a stack is always last in, first out, and a queue is first in, first out. Yeah, sure, post your solution. I'm always happy to see what other people did. As usually, I probably made this more difficult than it needed to be, but yeah. Let me strip out this inline stuff because it's messy. And it's possible that you that any links that you drop are not visible to other people. So let me just check it like this. If you have Telegram, this is my Telegram channel, and if you have Discord, let me get my Discord link. Let me put that in chat as well. So you probably need to send it through either of those, because YouTube will automatically hide anything that has a link in it in chat. I'm aiming for more performance this year. Yeah, that's something that you see a lot. Like if I bring up some of the Discords, there's the C# Discord, Advent of Code, and they always try to benchmark the crap out of stuff and make sure that you get the most optimal performance there. So they they benchmark everything and compete to try and get things down as much as possible, like to microseconds. And that's also something that I see in the CryptoMonkeys Discord. People really like to challenge themselves to make it as fast as possible. On your Discord, okay, let me see. Yes, let's bring that up. Let me see. So this is Keith's solution. Let me post it in chat here for those that want to read along. Let me see. Lines is read lines, parse stack definition file. Lines but take while not contains move. Okay. Where else? No empty white space. What are complete blank lines? I don't think so, right? Reverse, so the first things to push and stack are at the top. Sure. Skip one. So yeah, this is basically taking a link approach to parsing the header, which is still nice and readable. So yeah, that's good. The chunk 4. Oh yeah, I haven't used those new extensions yet, like .chunk. I don't know when they added it to C#, but that is very useful to chop up something in a fixed length. Because I wrote a whole, let me pull up my code to compare. Parse header. I worked out the same like chars per column and then did all sorts of loops just to extract that data and push it onto those stacks. So yeah, let's see, letter first default to list, yes. So this basically also parses that same stack into something workable. Let's see, my original version used lists and regexes to parse, more than twice as fast in my latest version. Let's see, I knew it would be range stack definition first count, select stack, new stack. Sure. So this builds it up, and then you get a list of stack of char, which is basically the same, Parse instructions, let's see, new instruction. And you -1 each instruction there. Yeah, I figured I added in the parsing so that it's after I realized that I was wrong, of course, because I didn't pick up on that instantly. Did you figure that out while coding it before running it? That the indexes were off by 1 and you needed to change them? As you saw, I didn't. I didn't account for it right away. Let's see, lines that skip while contains moves. Okay. Yeah, the skip while etc. is nice. Using link also seemed to slow down my results. Yeah, you have to. Link is a trade-off usually, but there's so many cool things that you can do and just save a lot of time. So link code is usually less verbose than writing all the stuff out yourself, so you can easier grok everything that's going. Extra point to realize it before running it, SMA be okay. I still don't know how to pronounce that name, sorry. Same as you, it went boom for Keith, yeah. No shame in that, at least. As I said, I've been doing this since I was 12, I'm nearly 40 now, still loving coding, but yeah, catching stuff like this, writing a code out perfect, without bugs the first time, is a rare occasion still. And it's usually a bit spooky, because you're like, why didn't anything break? Did everything work correctly? It's just part of it. It's just being able to actually debug your stuff, find the bugs quickly and move on, that really helps with programming. SMAP like lab, then UK. Okay, SMAP UK. Okay, got it. Let me read the code back. Move to. You split on the keywords. That is interesting. Why did you reverse the order? Just preference? From to and then count. Yeah, probably just preference then. I still haven't used the record yet. As you can tell, I've gotten used to writing value tuples, and one of the things that I really like is some of the extensions that I wrote. This can seem like such a wall of code, but there is a function here that's called as, that you can see here. And basically what it does, it just lets you transform anything with, and I have a few overloads that give me more, right? So I can see here that there's, I can't even find the name. Let me see. Yeah, so as, and as. There are three overloads for me, one with 2, one with 3, and one with 4 inputs. And what basically lets you do is transform any IEnumerable or string array or whatever, and transform that into something that you can name. So like what I do here, this assignment part, you can see me calling my extension here as, and that breaks just out into delegates that you can execute. And this returns a value tuple of type. And what you can do then is just make it a value tuple with the names that you want, so that you can get a nice object with all the named properties, so you don't have to do item 1 or anonymous things or things based on arrays. So I really like this structure, but you can do the same with records probably. But yeah, I just really like splitting it out like this and being able to, I do that pretty much every day. So do I have an as here? Yeah. So here you get to ranges and stuff like it. It just makes the code nice to work with, at least that's my preference. I should look more into records, which is basically like an inline struct that you define. That gives you a lot of the same advantages. Let me see, where was I reading? Oh yeah, here. So parse instruction, parse instruction. Stacks enumerable range. Okay, so like instead of a for each, you use this, and then do it like that. Yeah. Well, since I'm not sure that I prefer reading this over just a simple for loop, because it's for me this adds more noise, because we're so used to seeing like a simple for loop that constructions like this takes more time to read and understand. It's not that hard. It's just a simple preference. Let's see. In this case, a record struct is more efficient. Yeah, it's surely a lot very efficient. I'm sure of that. Let's see, any instruction count, select. So here you use okay. Yeah, it's the same, just with link to dump it into a list, then reverse it, and then go over it. By the way, if you, in this case, you don't have to call the toList, I think, to do the for each, right? Because it can just go as the IEnumerable. So you could save this toList here, but it doesn't matter that much. Here as well, probably. Because for each will just execute on IEnumerable. Yeah, so this is a mostly link solution. Not bad, I like it. I really like I should look more into the chunk and the records. It's been added like 1 or 2 years ago, I think, at least the record stuff. The chunk helpers, etc. I don't know in which version they added that, but it's nice and helpful for stuff like this. So yeah, thank you for sharing your code. And thanks for keeping me company with these Advent of Code streams. I have a lot of fun doing it. So yeah, I hope to see you again